Hello, welcome to zzTalk. In this session, we're going to continue the discussion about infrastructure as code. It's a big topic which has tons of tools in the market serving infrastructure as code practices. We've already talked a bit about Terraform, Docker in the previous sessions. If you watch my first video about Terraform, I talked about my confusion in the early stage when I got in touch with these automation tools. Today, I'd like to deep dive in comparisons between different infrastructure as code tools. Hopefully, it could help you one way or another to decide what tool or set of tools are the best fit to your scenario to practice infrastructure as code. Lastly, follow my tradition to have a hand-on lab session. I'm gonna jump to a popular configuration management tool, Ansible. There will be more presentation than usual in this session because I'm gonna compare tools from different point of views. I guess I won't have time to demo Ansible in detail in this session because it's gonna take too much time. I plan to break it into 2 or 3 sessions. In the lab part, I will just demo how to use Docker to set up an environment for testing Ansible, which I think is a good practice, by the way, of building our own Docker image if you watch my previous sessions for Docker. All right, cool. Let's have a quick review. The idea behind infrastructures as code is that you write and execute code to define, deploy, update, and destroy your infrastructure. This represents an important shift in mindset in which you treat almost everything of your operation as software. In fact, a key insight of DevOps is that you can manage everything in code, including servers, databases, networks, log files, application configurations, automated tests, deployment processes, and anything you can think of. So, to help us fulfill these tasks, we need tools, right? If you Google for IaC, it's pretty easy to come up with a list of the most popular tools in the market. However, what's not easy is figuring out which one of these we should use, considering we're not familiar with each of these tools, and it's hard to do detailed comparison, especially most of the comparisons are information we can find online between these tools. Do little more than just list the general properties of each tool and make it sound like we could be equally successful with any of them. So this is something I want to discuss to sort them out for you a little bit. Here I categorize IaC tools into 4 general categories. First, configuration management tools. They are designed to install and manage softwares on existing servers. Second, server templating tools. An alternative to configuration management that has been growing in popularity are server templating tools, such as Docker, Packer, and Vagrant. Instead of launching a bunch of servers and configuring them by running the same code on each one of them, the idea behind server templating tools is to create an image of a server that captures a fully self-contained snapshot of the operating systems, the softwares, the files, and all other relevant details. Right? Orchestration tools. So the server templating tools are great for creating VMs and containers, but how do we actually manage them? For handling these tasks is the realm of orchestration tools such as Kubernetes, AWS ECS, which is Elastic's container service, etc. All right, and last but not least, provisioning tools. Whereas configuration management, server templating, and orchestration tools define the code that run on each server, provisioning tools like Terraform, CloudFormation, and OpenStack are responsible for creating the servers themselves. In fact, you can use provisioning tools to not only create servers, but also databases, caches, load balancers, monitoring, firewall, almost every other aspect of your infrastructure. All right, next, I'd like to compare these categories from different angles. I'm sure you will have the same consideration when you are about to pick the right tools or tool sets for your use case. Firstly, configuration management versus provisioning tools. Like I said, Chef, Puppet, Ansible are all configuration management tools, which means they're designed to install and manage software on existing servers. On the other hand, Terraform is provisioning tool, which means it's designed to provision the server themselves, leaving the job of configuring those servers to other tools. Actually, these two categories are not mutually exclusive, because most configuration management tools can do some degree of provisioning, and most provisioning tools can do some degree of configuration management. But the focus on configuration management or provisioning means that some of the tools are gonna be better fit for certain types of tasks. In particular, for example, if you use Docker or Packer, the vast majority of your configuration management needs are already being taken care of. With Docker and Packer, you can create images such as containers or VM that have all the softwares your server needs already installed and configured. Once you have such an image, all you need to do is a server to run it, right? And if all you need to do is provisioning a bunch of servers, then a provisioning tools like Terraform is typically going to be the better fit than a configuration management tool. Mutable infrastructure versus immutable. Typically, configuration management tools default to a mutable infrastructure paradigm. For example, if you tell Chef to install a new version of OpenSSL, it will run the software updates on your existing servers, and the changes will happen in place. The problem is, over time, as you apply more and more updates, each server builds up a unique history of changes. These often leads to a phenomenon known as configuration drift, where each server becomes slightly different than all the rest, leading to subtle configuration bugs that are difficult to diagnose and nearly impossible to reproduce. On the other hand, if you're using provisioning tools to deploy machine images created by Docker or Packer, then every change is actually a deployment of a new server. For example, for the same example, to deploy a new version of OpenSSL, you would create a new image using Packer or Docker with the new version of OpenSSL already installed. Deploying that image across a set of totally new servers and then deploy the old servers. This approach reduces the likelihood of configuration drift bugs, makes it easier to know exactly what softwares are running on the server, and it also allows you to trivially deploy any previous versions of softwares at any time. The next comparison is about the configuration style between procedural and declarative. Chef and Ansible encourage a procedural style where you write code that specifies step by step how to achieve some desired end state. On the other hand, Terraform, CloudFormation, and Puppet all encourage a more declarative style where you write code that specifies your desired end state, and the IaC tool itself is responsible for figuring out how to achieve that state. A simple example, let's say we wanted to deploy 10 EC2 instances to run version 1 of an application. All right. Here is a simplified example of an Ansible and Terraform template. You can compare between them. The snapshot in the central node of my slice right here. The up is Ansible and down is Terraform. All right. So if you can, when you review the code at the surface, these two approaches look kind of similar, right? And when you initially execute them with Ansible or Terraform, they will actually produce similar results. But the interesting thing is what happens when you want to make a change. For example, imagine traffic has gone up and you wanted to increase the number of servers from 10 to 15. With Ansible, the procedural code you wrote earlier is no longer useful. If you just updated the number of servers to 15 and rerun that code, what happened it will deploy another 15 new servers, which giving you 25 servers in total, right? Which is not what is expected. So you have to be aware of what is already deployed and write a totally new procedural script to add the 5 new servers. However, with declarative code, since all you do is declare the end state you want, and Terraform figures out how to get to that end state, right? Terraform will also be aware of any state it created in the past. Therefore, to deploy 5 more servers, all you have to do is just go back to the same Terraform template and update the current, update the count from 10 to 15, like here, the snapshot in the right of my slide, right here. All right, now let's extend the example a little further. What happens when you want to deploy version 2 of the application is that with the procedural approach, both of your previous Ansible templates are again not useful anymore. So you have to write yet another template to track down the 10 server. Oh, actually, wait, it's not 10, it's 15 because we increased another 5, right? So you have to track down the 15 servers you deployed previously and carefully update each one to that new version. On the other hand, with declarative approach of Terraform, you just go back to the exactly same template once again and simply change the AMI version here from AMI-v1 to AMI-v2. That's it, right? Here you can feel the difference, right? So, by the way, these two examples are just simplified. Because Ansible, if you know Ansible actually does allow you to use tags to search for existing EC2 instances before deploying new ones. But having to manually figure out these kind of logic for every single resource you manage with Ansible based on each resource past history can be extremely complicated. That's the point. All right, and based on these example, we can highlight 2 major problems with procedural IaC tools. So when we're dealing with procedural code, the state of the infrastructure is not fully captured in the code. Reading through the Ansible template, for example, we created in the previous slide is not enough to know what's deployed. You would have to know the order in which we applied those templates. How we apply them in different order, we might end up with different infrastructure. And that's not something you can see in the code base itself. All right, that's the problem 1. Problem 2, the reusability of procedural code is inherently limited because you have to manually take into account the current state of the code base. Since the state is constantly changing, code you used a week ago may no longer be usable like today. As a result, procedural code base tend to grow larger and larger and complicated over time. Right? That's another big problem with procedural IaC tool. Cool. Next comparison is between master versus and masterless. By default, Chef, Puppet, and zzTalk all require that you run a master server for storing the state of your infrastructure and distributing updates. Every time you want to update something in your infrastructure, you use a client like a CLI tool to issue new commands to the master server, and the master server either pushes the updates out to all the client servers, or those client servers pull the latest updates down from the master servers on a regular basis. Master server does offer a few advantages. For example, it's a single central place where you can see and manage your the status of your infrastructure. Many configuration management tools even provide a web interface for the users to make it easier to see what's going on of their infrastructure. Second, some master servers can run continuously in the background and enforce your configuration. That way, if, for example, if someone makes a manual change on a client server, the master server is able to detect it and revert that change to prevent configuration drift. However, having to run a master server also have some some serious drawbacks. For example, extra infrastructure. You have to deploy an extra server or even a cluster of servers to host your master. Just host it, right? And maintenance. You have to maintain, upgrade, backup, and monitor your master server. And security. You have to provide a way for the client server to communicate to the master server, and also a way for the master server to communicate back to all of the client servers, which typically means you have to open extra ports and configuring extra authentication systems, all of which increases your surface area to attackers, right? By the way, Chef, Puppet, and zzTalk do have varying levels of support for masterless mode, where you just run their agent software on each of the client servers, typically on a periodical schedule, like a cron job, and use that to pull down the latest updates from version control. These actually significantly reduces the number of moving parts, right? But as discussed in the next slides shortly, this still leaves some questions unanswered, like how to provision the servers and install the agent software on them in the first place. On the other hand, Ansible, CloudFormation, Terraform, they're all masterless by default, or to be more accurate, some of them may rely on a master server, but it's already part of your the infrastructure you're using, and not an extra piece you have to manage separately. For example, Terraform communicates with cloud providers using cloud providers' APIs. So in some sense, the API servers are the master servers, except they do not require any extra infrastructure or any extra authentication mechanisms. And like Ansible works by connecting directly to each server over SSH. So again, you don't have to run any extra infrastructure or manage extra authentication mechanisms. Just use your SSH, right? Okay, next slide. So we talk about master, we talk masterless. Of course, we're going to talk about agent versus agentless. Chef, Puppet, and SauceStack all require you to install agent software on each server you want to configure. The agent typically runs in the background on each server and is responsible for installing the latest configuration management updates. There are a few drawbacks, like bootstrapping. How do you provision, like the question we mentioned in previous slide? How do we provision your servers and install the agent software on them in the first place? Some configuration management tools kick the can down the road, assuming some external process will take care of this for them. For example, you first use Terraform to deploy a bunch of servers with a VM image that has the agent already installed. Other configuration management tools have a special bootstrapping process where you run one-off commands to provision the servers using the cloud provider APIs and install the agent software on those servers over SSH. Maintenance. You have to carefully update the agent software on a regular basis, being careful to keep it in sync with the master server if there's one. And you also have to monitor the agent software and restart it if it crashes. Security. If the agent software pulls down configuration from a master server, then you have to open outbound ports on every server, right? And if the master server pushes configuration to the agent, on the other hand, then you have to open inbound ports on every server. In either case, you have to figure out how to authenticate the agent to the server is talking to. All of these increases your service area to attackers again, right? On the other hand, Ansible, CloudFormation, Terraform do not require you to install any extra agents, or more accurately, some of them require agents, but these are typically already installed as part of infrastructure you're using. For example, AWS, Azure, GCP, and all of the other cloud providers take care of installing, managing, and authenticating agent software on each of their physical servers. So as a user of like Terraform, you don't have to worry about any of that. You just issue commands and the cloud provider's agents execute them for you on all of your servers. And with Ansible, your servers need to run the SS daemon, which is common to run on most servers anyway, right? All right. We have done a lot of comparisons so far, and hopefully you don't get bored. But the point is, although I have been comparing infrastructure as code tools, in reality, most likely we're gonna need to use multiple tools to build our infrastructure. Here I list like a couple of common combinations that I've seen popular and work well. The first one is provisioning plus configuration management. A good example is Terraform and Ansible as a bundle. That's actually what my work environment's choice. We use Terraform to deploy all the underlying infrastructure, including the network topology like VPC, subnets, route tables, and also data stores like database, Redis, load balancers, you just name it. You then use Ansible to deploy your application on top of those servers. This is a very easy approach to start with, as there is no extra infrastructure to run. As you know, Terraform and Ansible are both client-only applications, and there are many ways to get Ansible and Terraform to work together. A good example, Terraform adds special tags to your servers, and Ansible uses those tags to find the server and configuring them. But the major downside is that using Ansible typically means you're writing a lot of procedural code with mutable servers, right? So as your code base, your infrastructure, and your team grow, the maintenance may become a problem because it's kind of become more difficult. The second good combination is provisioning plus server. A good example is Terraform and Packer combination. You use Packer to package your applications as virtual machine images, and then you use Terraform to deploy servers with these virtual machine images and the rest of your infrastructure, including the network topologies, data stores, and load balancers. Just exactly the same thing like I mentioned in the previous combination, Ansible plus Terraform. This is also an easy approach to start with, as there is no extra infrastructure to run. Moreover, this is an immutable infrastructure approach, which will make maintenance much easier than the previous option. However, there are two major drawbacks for this approach or this combination. Firstly, virtual machines can take a long time to build and deploy, which will slow down your iteration speed. Secondly, the deployment strategies you can implement with Terraform are limited. For example, you can't implement blue-green deployment natively in Terraform. So you either end up writing a lot of complicated deployment scripts, or you turn to orchestration tools, as described with comes the third popular combination below. Provisioning plus server templating plus orchestration. Example is Terraform plus Packer plus Kubernetes. So let's say you use Packer to create a virtual machine image that has Docker and Kubernetes installed. And you then use Terraform to deploy a cluster of servers, and each of which runs these virtual machine image and the rest of your infrastructure, including the network topologies, same thing, data store and load balancers, etc. And finally, when the cluster of servers boots up, it forms a Kubernetes cluster that you use to run and manage your Dockerized applications. So the advantage of this approach is that Docker images build fairly quickly compared with Packer virtual machine image build. You can run and test them as on your local computer, and you can take advantage of all the built-in functionality of Kubernetes, including various deployment strategies, auto-scaling, auto-healing, and so on. On the other hand, the drawback is the added complexity, right? Is apparent. Both in terms of extra infrastructure to run and in terms of several extra layers of abstraction like Kubernetes, Docker, Packer to learn, manage, and debug. There's a steep learning curve, right? It's pretty much what I want to share today. I know it's been a long talking for this session, but I do hope it help you one another to understand better between these tools and make better decision when you have to decide which tool or tool set you need to use for your use case. All right. Now let's jump to the last part, the demo. Like I've said in the beginning, I won't have time to talk more detail about Ansible, but it won't hurt to do some preparation for the next session. Let's review what we have learned about Docker so far, and let's create a custom Docker image to prepare our Ansible testing environment for the next session. And it's pretty simple, and all we needed is to install a Linux-based image and then enable SSH on top of that Linux-based image. That's pretty much it. So cool. Let's jump on it. All right. The idea is pretty simple. So here for this image, I've already write down the framework, what we need to configure step by step. So the idea is pretty simple. We just need a base Ubuntu image, and on top of the Ubuntu, we need to install SSH, VI, those necessary apps on top of Ubuntu, so we can access SSH. So because Ansible is masterless, we just need to create this image and use this image to spin up a couple of Ubuntu servers, and we're gonna use one as the master and the rest as the client, and we set up the connection over SSH. That's pretty much the reason we need to install SSH on each of the servers. That's pretty much it. So for a review or a little test, you can just go ahead to try to write the configuration yourselves based on this framework. I will let you go ahead, and if you don't know or you need some reference, you can watch. I will write with you line by line. All right. So the first step, Ubuntu base image. As you remember, when we create a Docker image, we need to create a file called Docker uppercase D Dockerfile, and then inside of this file, remember those basic syntax. We need to start with from base image. If you also use Visual Studio Code and you install that plugin, Docker plugin, it will give you a hint, right? So this time we're gonna use Ubuntu, latest version of Ubuntu as the base image. So I'm gonna use Ubuntu and tag is latest. All right, that's the first step. And we got the base image, and then we're gonna need to install the softwares like openssh-server, VM to Ubuntu. So we're gonna use that package manager. We're gonna do run app update first, and app install openssh server and sudo vim and -my. Basically, I just use that the package manager. Firstly, update the package manager, and then install openssh server, sudo vim. These -y argument basically, so it's automatically answer yes when you install the software. All right, pretty simple, right? Next, create a user. So we're gonna create a system account for Ansible. So what we're gonna do? We're gonna do run same thing. Run user at name -d and home Ubuntu -s bing bash and -g root and -g sudo and u100,000. Sorry, and I'll give the user name as zzTalk. All right, and basically the command, if you're familiar with Unix command, is just the useradd command to add user, and the -rm, -r basically means create a system account, and m creates the user's home directory if it doesn't exist. In this case, I'm gonna give the home directory name is home and Ubuntu. All right, and as basically it's a shell, I'm gonna use bin bash shell for these user account as the default shell, and -g basically means group, the group name or number of the user's initial login group, right? And it belongs to root, and hyphen uppercase G is a list of supplementary groups which the user also a member of, right? And 1000 -u1000 basically is the numerical value of the user's ID. The values, between 0 and 999 are typically system used values. So the first custom value start with the 1000, so which is in our case this guy, and I give the custom user as zzTalk. Cool. Next step, we set up the username. We're gonna set up the password for these accounts. Sorry, I'm gonna do again run, and I'm gonna do a cool. We'll give a password also zzTalk, and pipe these commands and these password to change password. chpasswd change password. All right. Basically, this command means I'm gonna pass these zzTalk as password to zzTalk admin, this zzTalk account ID basically. And next step, we're gonna expose SS port 22. Before that, we're gonna run. Actually, here, this was this step. So create an account and create a password for this account. And next, we're gonna start SSH as a service. What are we gonna do? We're gonna do run again and service SSH start. And then we're gonna expose the port SSH port, which is 22. So we're gonna use expose 22. Last but not least, we're gonna add the startup script, right? We're gonna give the executable, which is the path. The first is the path of the SSH. So it's user Spain SSH, and the arguments Alright, that's pretty much it. Let's save it, and we're good to go. And let's open up the terminal and go to zzTalk, and here is my Dockerfile, right? So we need to use the Dockerfile to build a Docker image. How do I do that? Remember, we're gonna run that command. We're gonna run docker build dot, and actually dot, we're gonna give a tag. I'm gonna call it zzTalk / Ubuntu-SSH. All right, and give a latest and dot. Here we go. Hit enter, and it start building the image. Let's give it a little bit time. It should be pretty quick. And as you can see, it's installing the openssh and Vim. All right, that's it. Pretty quick, right? And now let's just issue Docker, and you can see naming to Docker zzTalk Ubuntu SSH. And if you search for Docker images, and you can see the image was created successfully. Now the image is ready, so we're good to go ahead to spin up a couple of instances out of these image containers. All right, so to spin up a couple of containers, the command is also pretty easy. Docker run, and I'm gonna give the name of the container as Ubuntu 1, and the host name is also Ubuntu 1, and I'm gonna run it as the detach in the back, so it will run in the background. And the image I'm gonna use is the one I just created, zzTalk Ubuntu SSH, and I'm gonna use the latest tag. All right, so hit enter. And you can see one of the container was already created. And if you run Docker ps, and you can see it's up and running, right? So we're gonna use this Ubuntu 1 host as the master. Let's spin up another couple of containers so as the client, so we can set up the like a little environment or infrastructure to test out Ansible. And same command, all I need to just change, I just need to give another name. Instead of Ubuntu 1, I'll call it Ubuntu 2, 3, 4, like that, right? Ubuntu 2. Alright, Ubuntu 3. So I think 3 client will be good enough. So I will do, this is the first one, this is the second, and this is the third, which is 4. Hit enter. All right, and if you run Docker ps again, and you can see there are 4 containers up and running. Cool. Now, as we design, we're gonna use the first one as the masters, right? So we need to log into this container and install Ansible in this container. All right, so let's do that. Before I jump to the first container, let's go to the browser and log on Ansible's official websites, and just search for Ansible installation Ubuntu, right? And click that and find Ubuntu here. Or in your case, if you're not installed Ubuntu in your image, for example, test other base image like Red Hat CentOS, just follow the instruction accordingly. Here I pick Ubuntu, and here those are the installation instructions we need to run. These 4 commands on the first container. Let me log on to the first container. Docker. Let me expand a little bit. Okay, Docker 1 container. So remember the command, Docker x-it, and the name of the container we need to log on, which is Ubuntu 1, and the bash. I'm gonna use Bing bash. And here you go. I logged in as root on this container. And now if we do a su zzTalk, remember in the Docker image we created a custom ID whose name is zzTalk, right? And you now see I log in as zzTalk now, and if I do a pwd, and you can see the home directory of zzTalk is /home/Ubuntu, which is exactly what we configured in our Docker image, right? Looks good, just a verification. And now I'm gonna follow the step and issue this fork command accordingly to install Ansible. I already did it to save us some time. I already run this command on these container. And let's just test out by issuing Ansible version to make sure Ansible was installed correctly on these container. And you can see it looks good. I'm on version 2.9.6. Cool. Installation is done. Next, we're gonna do some simple configuration like inventory. As you know, for Ansible, be able to communicate with the rest of the servers over SSH, we have to create a inventory files of Ansible. We're gonna refer that file to understand what groups each individual service belongs to and what are they, right? So let's create that. And by the way, if you issue this command, Ansible version command, you can also see this is the location where the Ansible configuration files were stored. All right. By the way, so if you do not create a custom inventory file, this is the default location where the default inventory locates. So if you do not create your own custom inventory, the Ansible gonna refer to this default inventory file, which is etc Ansible hosts, this guy. All right. So for our case, we're gonna create our own inventory file. So here I'm on the Ubuntu. If I issue a host name, I'm on this Ubuntu 1 container. So under this home Ubuntu directory, my ID, zzTalk, I'm gonna create a custom inventory. So we're gonna just name it my inventory. The text. All right, hit enter. So here, let me give you some basic introduction of the syntax of inventory. I'm gonna start with alias. As you remember, we have 3 clients installed other than the master host one, Ansible 1. Ubuntu 1, right? So we're gonna create alias for each of them to give a role of that container, so we know what that container for. For example, I'm gonna give the Ubuntu 2 container as web server. So I will call it web as the alias, and Ansible _host. As Ansible _host, it's a inventory parameter used to specify the FQDN or IP address of that server, right? So here after that, I'm gonna call it IP address, which is actually you can grab the IP address. Let me open another terminal. So Docker PS, and you can do Docker inspect of a container to grab the IP of this container, and pipe and gonna grab attach IP address. And here you go, for container Ubuntu 4, and the IP is 72.17.0.5. Same thing you can do grab for other containers to grab the IP accordingly. So let's do 3, which is 4, and 2 is gonna be 3. All right, so we got the IP, so we're gonna add this IP, assign this IP to the Ansible host for each of them in the inventory file. So let's jump back to the inventory file, and we're gonna designate the host 2 as the web server, and here double check the host 2. Where's host 2? Ubuntu 2. The IP address of Ubuntu 2 is 0.3, so we're going to copy that and paste over here. All right. The next variable is Ansible _connection. Basically, this is another inventory parameter to specify how are you going to connect to these hosts from the master. So because we're all using Linux-based system, so we're just gonna use SSH connect to these hosts from the master, right? And next we're gonna give another parameter, which is Ansible-user. This is basically the parameter apparently to define what user ID you're going to use to run Ansible, right? For our case, we're going to use the ID we created, which is zzTalk. And we got the ID. We need to put another parameter, which is password, right? So Ansible /pass. We're gonna give zzTalk again. So here, this is not a good practice for production environment to include the password inside of these inventory file. It's a security concern, obviously, right? But for our test case, I just put it here, so it's just for testing purposes. But for you in your production, the best case scenario is the best practice is use the SSH key. All right. So we got the pretty much all we need, and we're gonna do the same thing to the rest containers. So we're gonna copy here and give a role for the other servers. For example, the next one is Ubuntu 3. The IP address is 0.4. So we're gonna give 0.4 a role also as web server. So we're gonna have 2 web servers and 1 database at the back end. Like just mimic a simple architect, front end, back end architect, right? And same thing, SSH, username is zzTalk, password is zzTalk, and next one is Ubuntu 4, and the IP is 0.5, and we're gonna 5, and we're gonna give the alias as BB, and here we're gonna give this is web server 1, this is web server 2. All right, that's pretty much it. Let's save this file, and we are done with the inventory. By the way, another thing we can do, let's edify my custom inventory again here. So besides giving alias of each of the individuals, we can create whatever group we want to group these individual containers. So for example, the first two containers gonna be act as web server, right? So we can create a group as web server. Syntax is we can need to create a stanza web _ server. This is gonna be the group name we can call when we, for example, we need to issue specific command on a web server. We can just call this group, use this group name, and we're gonna include the alias. Web 1 and web 2 belongs to this group, right? And we can create another group. Let's call it DB server. And we include the DB, which is host Ansible 4. Host name is Ansible 4, right? That container gonna be act as that database. And we can also create a all group to include everything. So in that case, so we can do what would you call? We're gonna create a parent group. So to include all those child group inside of that parent group, the syntax is like this. I'll include that. The syntax is something like this. We're gonna give the parent group name here and colon and children. And in our case, we're gonna call it os_server, and that's our parent group name and children, and web server group and DB server group. These two groups are the children group of our server group. All right, that's pretty much it. So let's just save it. And one more thing we need to take care of before we can verify if the communication between these master and client worked, right? So what we can do, we need to modify these /c hosts file to include the IP and host name like this. Already done on all of these servers, so you need to do the same thing if you follow my steps. So edit the IP address and host we created, the containers we create inside of the /c hosts file for each of the containers, so they know each other, the DNS name right here. All right, cool. That's pretty much it. We can go ahead to do a quick pin test from the master Ubuntu 1 to see if the Ansible works. Is Ansible able to ping the command? The ping on these three client servers, right? So the command is called Ansible. Ansible, and we're gonna include the group target group. In our case, we're gonna ping on all three servers, right? So we're gonna use that all server group. We call it all server or all servers. Let's double check. all server. All right. So we just need issue Ansible, and the target is all server. And we're gonna use the ping module with when we use modules, we're gonna use -m and the ping module, right? And we're gonna define, we're not gonna use the defaults, we're gonna use the inventory file we created. So use -i to include our inventory file. All right, so just hit enter. All right, let's double check my inventory file one more time. And sorry, there was the typo, children, DREN. Sorry about that. And let's try one more time and do Docker. Sorry. So we're gonna run Ansible all server. We're gonna do that pin test on all 3 client servers, right? So, and I'm gonna include the ping model with -m argument and ping, and -i to include my custom inventory file. Otherwise, if you don't include this file, you're going to use the default inventory file, as I mentioned earlier, right? So hit enter. Okay, another error. It says to use SSH connection type with password, you must install SSH pass program. So that's the issue, and here's the solution. So it is the host machine which needs the SSH pass program installed. So for an Ubuntu machine such as 16, it's as simple as just install SSH pass. All right, let's do that. I'm gonna run this command install as root. And cool, let's issue back to zzTalk and try the same command one more time. Here we go. Aha! Now it worked, and you can see the status all success across 3 containers. All right, looks good. So we pretty much set up our testing environment for Ansible. Let's call it a day. It's been almost an hour, I guess. So let's take a rest, and that's pretty much what I want to share for this session. And let's continue on Ansible in next session. All right, cool. Appreciate and thank you for watching. Remember, thumb up and subscribe to the channel. All right, see you next session.